Hello, this is lesson 20 on Buffon's needle, an old probability question from the 18th century. The question states, if a needle is dropped onto a piece of paper with equally spaced parallel lines, what is the probability that the needle crosses one of the lines? Now, we're going to do a special case here where we're going to assume that the distance between the lines is 1 unit. And we're also going to assume that the length of the needle is 1 unit. We're going to define D to be the distance from the midpoint of the needle to the closest line. And so, since the distance between the lines is 1 unit, and we're picking the closest distance, that distance cannot be more than 1/2. Otherwise, the other distance would be even larger and the total would go above 1. So the distance from the midpoint of the needle to the closest line is between 0 and 1/2. And then we're going to define theta to be the angle between the needle and a line through the midpoint of the needle that's parallel to the lines on the paper. And this angle will be between 0 and pi. D, this is a question to think about. Are these two variables, D, the distance from the midpoint to the closest line, and theta, the angle the needle basically makes with a line parallel to the lines on the paper passing through the midpoint, are those variables independent? All right, let's take a look at a picture here of the situation. So again, we're assuming the distance between the lines is 1 unit. We're assuming the length of the needle is 1 unit. We've defined D to be the distance from the midpoint of the needle to the closest line on the paper. And we've defined theta to be the angle that the needle makes with a line parallel to the given lines and through the midpoint of the needle. Now, since we know the needle has a length of 1 unit, and we're looking at the midpoint here, we know that it's 1/2 on either side. So this distance is 1/2. Okay, so we look at this right triangle here, and we have a line that's parallel to D. So that's going to be perpendicular here. The distance is measured perpendicular. So that's going to be perpendicular to our parallel line. So we have a right triangle. We see the hypotenuse is 1/2 because it's half the length of the line. And we're looking at the angle theta with the parallel line and the needle. So using some trigonometry here, from right triangle trig, the sine of theta is equal to the opposite side over the hypotenuse. And we know the hypotenuse is 1/2, so we can solve for this vertical segment here, the opposite segment, by cross multiplying. It's hypotenuse times sine theta, which is 1/2 sine of theta. So in order for the needle to intersect the closest line, we need the distance D to be less than or equal to 1/2 sine theta. All right, so we're going to do some calculus for that here. So graphing 1/2 sine theta from 0 to pi, and along the vertical axis, we're measuring the D distance here, and that went from 0 to 1/2. So we want to know the probability that D is less than or equal to 1/2 sine theta. So it's essentially this we have to measure this blue area compared to all possibilities, which is inside the rectangle. So the shaded area under the curve of 1/2 sine theta, that's the first step here. So we're doing the definite integral from 0 to pi, limits on theta, of the function 1/2 sine theta d theta. That'll give us the area under the curve and above the horizontal axis. The antiderivative of sine theta is a negative cosine theta. 1/2 stays attached. Remember, derivative of cosine is negative, so the integral of sine is negative cosine theta. Evaluated from 0 to pi, so we're going to have cosine of pi minus cosine 0. Cosine of pi is -1. Cosine of 0 is +1, and we're subtracting. So that yields a -1/2 times a -2, which is a +1. So the area of the blue shaded region is +1. That's +1. Now, what's the total area here? The total area is the area of the rectangle. There, the rectangle is length times width. The distance across is pi, and the vertical component is 1/2. And so the total area is pi over 2. So the region that satisfies the condition we want for the crossing of the needle intersecting the line, that has area 1. The total area representing all possibilities is pi over 2. So the probability of a success here is 1 divided by pi over 2. And then that flips over to 2 over pi, which is approximately 0.6366. So again, assuming that the length of the needle matches the distance between the lines, then the probability of a crossing is 2 over pi, which is about 0.6366. And it's interesting that there's a pi in this answer, so you could actually perform this experiment and get an estimate for the value of pi.